Now we can see the PN junction in reverse biased condition operation. When positive terminal of the battery is connected to the cathode or N-type material and negative terminal of the battery is connected to the P-type or anode of the PN junction, then this type of arrangement or this type of setup is called reverse bias as shown in the figure. Now you can see in this p-type region we have holes, n-type region majority charge carriers are electrons, depletion region we have when PN junction is reverse biased, that is the negative terminal attracts the negative terminal of the battery attracts the holes which are present in the positive p region of PN junction away from the junction. They will be attracted towards plate, this plate of battery. In the similar way, the positive terminal of the battery attract these free electrons in the N region away from the junction and towards the battery. Now, no charge is able to cross this junction as electrons and holes move away from the junction, right? Yeah, the depletion region widens. This is the depletion region, it will get widened. Hence, the resultant potential barrier is increased, which prevents the flow of majority charge carriers in both the directions. Therefore, theoretically, no current should be flown in external circuit. But in practical, a very small current of order of few microamps flows under reverse biased conditions. Let us see why this current will be produced. Electrons forms covalent bond in the forming covalent bond in the semiconductor of an atom in p-type and n-type region may absorb sufficient amount of energy from heat and light to cause breaking of covalent bond. Hence, electron hole pairs are continuously produced in both the regions. In this p region as well as n region, we are having covalent bonds in the semiconductor. Due to heat and light energy, these electrons or hole pairs absorb the energy and they'll get a breakdown of covalent bonds. Hence, the electrons and hole pairs are continuously produced in both the regions, P region as well as N region. These will cause current. Under the reverse bias, the thermal energy generates holes in P region and are attached towards the negative terminal of the battery, and electrons in the N region are attracts towards the positive terminal of the battery. Consequently, the minority charge carriers, that is electrons in the P region and holes in the N region, or wander over the junction and flow towards their majority charge carriers. giving rise to a small reverse current. This current is known as reverse saturation current, which is I naught. That is, this p junction contains minority charge carriers. Those are electrons. They try to move towards the n-type region, and in this n-type region, they having holes as minority charge carriers. They are trying to move towards the p-type, which will produce a small current, that is saturation current. The magnitude of reverse saturation current mainly depends upon this junction temperature, because major source of minority charge carriers is thermal broken covalent bonds. A careful point, be careful to listen this. The minority charge carriers here are electrons. They try to cross the junction, and in n-type region, the minority charge carriers are holes. They try to cross the junction. Due to thermal energy, they can cross the junction and produces this reverse saturation current. Already free electrons from n side are flowing towards the positive terminal of the battery, and the newly liberated electrons from here will join with the majority charge carriers. Thus, a large amount of free electrons are formed, which commonly called as an avalanche free electrons. This leads to breakdown of the junction, leading to very large reverse current. The reverse voltage at which the large reverse current, the reverse voltage at which the junction breakdown occurs is known as avalanche breakdown.